Hi everyone. I just thought I would go through scientific notation with you to help you guys remember what to do before you guys get on to Delta Math and complete the 3 small sections. This should be review. A lot of you I know remember how to do it. We just want to make sure it's easy to go and ready for you guys. So we're going to make sure that we can write numbers in scientific notation, make sure we can go from scientific notation to standard form, and then multiply and divide when numbers are in scientific notation. Okay? So remember, some things to remember. Scientific notation, when you have a number times 10 to the power of something. Okay? You got to remember, this is the one and only time you can have negative exponents. Remember, the exponent tells us how far to move our decimal point, either to the right or to the left. Okay, if it's a positive, we know it's making a bigger number and we move the decimal point to the right. And if it's a negative, our number is less than 1, which means we move our decimal point to the left. Okay, remember, for it to be in proper scientific notation, there can only be one number, one value in front of the decimal point. So if we look at the bottom of this page, the first one, 3.22 times 10 to the negative third, that is in scientific notation, you guys. Remember, only one number in front of the decimal point and your exponent, okay? 32.2 is not scientific notation. Remember, we've got 2 digits in front of the decimal point. 5.23 times 10 to the 4.5. Remember, think about it. There's only one number in front, which makes the first part correct. However, you cannot have a decimal point for your exponent. Your exponents need to be integers. 23 times 10 to the second power. This is not, because again, even though we don't see it, our decimal point is behind the 3, which means there are 2 numbers in front of the decimal point. And then 6.2 times 10, think about it. We talked about this. Everything has an exponent, so this would be scientific notation because there is that exponent of 1 there. We know we can write the following in scientific notation. Every number, if there's not a decimal point there, we know that decimal point is at the end. We need to move the decimal point so it's between the first 2 non-zero. So we know we need to get it between the 4 and the 7. So we know we're going to move it 1, 2, 3, 4 places. So that means we would have 4.7 times 10. And since our number is bigger than 1, we know our exponent would be a positive 4. Now, if we look at the second one, we're moving the decimal backwards. We know this number is smaller than 1, so we know that this exponent would be negative. We know we want to get the decimal between the 3 and the 7. 1, 2, 3. So then we get 3.7 times 10 to the negative third. All right, that should be a nice review of doing this from middle school, from science classes, which is good. Now, standard form, it's the same way, except we want to move that decimal point however many places that exponent is, so we get the number in the big expanded form. Which these work, but we don't want to have to do operations with these. So if it's 10 to the if we look at example 3, 8.3 times 10 to the 4th power, it's a positive exponent, so we know we're going to move our decimal to the left. So I'm going to try to write this out for you guys. We have 8, 3. We know our decimal point's here. We're going to move it 4. 1, 2, 3, 4. And all these empty place values, we're going to put in zeros. And you can just go through and put your commas in. Okay? We also know when it's a negative exponent, we're going to move the decimal then to the left. 1, 2, and put a 0 in front and behind. Okay, so now we have to remember, sometimes people do not put our numbers in proper scientific notation. So that means we need to make sure it's always in proper scientific notation. We know for it to be in proper scientific notation, we only can have one number in front of the decimal point, and it has to be a non-zero. So if we look to get it in proper scientific notation, you guys, sorry about that. If we want to get this in proper scientific notation, you guys, we need to get the decimal point on 12.25 in between the 1 and the 2. So as you can see, we moved our decimal 1 to the left. If we're going to move to the left, you guys, that means we have to add add the number of place values. Okay? So we took 2 plus 1, which gave us 3. If you ever have to move the decimal point to the right, you are going to subtract that number of place values. So if you look at the next example down here, we had 0.248 times 10 to the 5th. Our decimal had to go back to the right 1 place value, so that means we subtract. One thing I'm going to tell you now, you guys, you need to remember and be careful with positive and negative numbers. That's where sometimes we make mistakes. So if we look at example 1 down here, we know we've got to move this decimal point 2 places to the right to get it in the right spot. And we know if we're going to the right, we have to subtract a really ugly 2. So that means we are going to be left with 5.3 times 10 to the negative 6. And it's not shrinking it up for us. Okay? Now if we look at number 2, we see that our decimal, again, is always after. We have to move it 1 to the left. So if I move to the left, I'm going to add 1, which then gives us 1.6 times 10, and negative 6 plus 1 is negative 5. I will make sure to post all these notes on Google Classroom with these so you guys can make sure you can look at these for examples also. Now, if we look, sometimes they're going to give us problems where we have 2 numbers in scientific notation we have to multiply or divide together. We want to do this because if you look at these and we wrote these out in big normal form, it's going to be a lot of work to do. Okay, so if we look at this, if you think about order of operations and about the concepts we've gone over this year, you got to think about how you would solve a problem like this. And again, think of like terms. Think about combining like terms for here. And when we do problems like this, you are going to use the operation given and you're going to just combine like terms. And you have to remember your rules for exponents and proper scientific notation. So if I have 3.5 times 10 to the 4th power times 2.1 times 10 to the 5th power, all we are going to do is combine our like terms. So what I mean by that is we are going to take the 3.5 and multiply it by the 2.1, just like I have here, which gives us 7.35. Then we take the 10 to the 4th power times 10 to the 5th power. We know that if we are going to multiply bases that are the same, down here, we end up adding the exponents, and that gives us 10 to the 9th power. Now we have to look. Our final step should always be, is this number in proper scientific notation? As we look, we see it is because there is only one number in front of the decimal point. So that's all we're going to do. And all we're going to add on is either multiplying or dividing. So if I look at this first problem over here, you guys, I've got 3.2 times 4.1. So again, what this is telling us to do is to multiply those two numbers together. We know if we multiply them together, you are just going to go 3.2 times 4.1, and we get 13.12. So we have 13.12 times 10, and we know then we have to take these two, and those are like terms, and we add those exponents, which again, 4 plus 6 is 10. All right, so we've did the first part where we combine like terms. Now we have to look at this. If we look, this first, our 13.12 is not proper scientific notation. We have to move this one place to the left. And we know if we move to the left, we are going to add. So I'm going to go plus 1 to the exponent. So with that being said, we are left with 1.312 times 10 to the 11th power. Okay? Now, on a division problem here, you guys, you're going to do the same concept, except instead of multiplying, we divide. So again, when we look at problems like this, we are going to divide 3.2 divided by 2. And we get 1.6. Whoops. Times 10. And now remember, when we are dividing bases that are the same, we subtract the exponents. We have 5 minus negative 3. So that means these turns to a plus. So we get 10 to the 8th power. Okay? And we look, our last step, are we in proper scientific notation? And we look, there's only one number in front of the decimal point, so we are in it, in correct form. Now I realize my camera is in the way of another one, but let's practice our last division problem. So again, we're going to go 8.4 divided by 2.1, and we get 4. So we get 4 times 10. Now again, like we talked about, since it's a division problem, we are going to subtract the exponents. Negative 4 minus 7, which gives us an exponent of negative 11. All right, so there we go. There is our review of scientific notation and multiplying and dividing when numbers are in scientific notation. Like I said, I will put the examples up there. Remember to make it in proper scientific notation. If you move to the left, you add that place values. If you move to the right, you subtract those. If you have any questions, let any of your teachers know, and we will help you. Have a good rest of the day.